Hey everyone, Mr. Fransky here again. I'm recording this video in the pod, so it's kind of echoey. We'll see how this goes. But hopefully at least my pen will work better than the last time. We kind of had some issues with it moving my slides around, so we'll see. So today we're going to talk about proving that a function is increasing or decreasing, so students will be able to use calculus to determine where a function is increasing and decreasing. Pretty straightforward. So let's take a look. So derivatives, stuff we've been talking about a lot, increasing and decreasing functions. That's really all we have to know. That should be a lot shorter than the last video. I'm counting on it. So, using calculus, when is a function increasing and when is it decreasing? So let's kind of think about a polynomial, maybe a cubic, okay? So it's easy, you guys know, right? It's decreasing up until this point, go left to right. You can think about slope dude standing on the function if you want to, right? So nice negative, right? He's going down the slope, negative, right? And then he increases up till this point and then decreases for the rest of the time. Now, there's a way to think about this actually using calculus. So notice, when he's decreasing, what do you notice about the slopes of all those lines? They're all negative, right? So that means that the derivative, f prime of x, would be less than 0. When we're increasing this entire time, that whole time f prime is greater than 0. And then the rest of the time here, f prime of x is less than 0. So this is a really short and sweet way to say that a function is increasing or decreasing just if the derivative is positive or negative. Now there's a reason for this, and the reason we waited to talk about this until mean value theorem. Mean value theorem says f prime of c is equal to f of b minus f of a over b minus a. And this is called a corollary to this theorem because it comes directly from this. So let's think about it. If you want a function to be increasing, so let's do a line, something simple. Here's a, here's b, here's f of a, here's f of b, up here. Notice that b minus a, if we're going from left to right, b minus a is always positive. Okay, that's always going to be a positive number. If the function is increasing, f of b minus f of a is also going to be positive. So if it's increasing, it's going to be positive. If it's decreasing, think about it this way, right? If it's decreasing, f of b, so if b is further along than a, f of b is going to be less than f of a, so f of b minus f of a would be negative, right? So the bottom is always positive because b is to the right of a. The top, though, could be increasing as positive, decreasing as negative. So f prime of c, that means that the derivatives in between those 2 points, a and b, will always be positive or negative. And if you were talking about at a point, you can just squeeze a and b really close around that point, and then you can say, well, the derivatives in between there are all negative, so it tells you it's going to be increasing or decreasing just by that. So to kind of put this into a summary, this isn't the end of the slides yet, but I'm going to do a couple examples. But so in summary, so if it is increasing, sorry, I'm going to do it this way. So f prime of a certain value of x is greater than 0, then the function is increasing at that moment, at that x value. If f prime of x is less than 0, f of x is decreasing. And if f prime of x is equal to 0, then the function is constant for that moment. Okay, so like at this point right here, 0 derivative. At this point right here, 0 derivative. You are neither increasing nor decreasing, right? So let's try this with an example. So on what intervals is the function f of x equals x e to the x increasing? When is it decreasing? All we have to do is take the derivative. F prime of x, we have to use product rule. So I have 1, so just x, derivative of x is just 1, so I have e to the x by itself. Plus, now I leave the x by itself, and I take the derivative of e to the x. Well, derivative of e to the x is just e to the x. So right away, it might be tough to say when this is positive or negative, because that's going to tell me when the function's increasing or decreasing. But I'm going to factor this. It has e to the x in common, so I have e to the x times 1 plus x. Now, e to the x, we know, as a function, is always positive. Right? The values of e to the x are always positive. So that means that if this is always positive, we're only going to be determined whether we're positive or negative by 1 plus x. Okay, so I want to know when is 1 plus x greater than 0 and when is 1 plus x less than 0. Well, I just subtract 1. So when x is greater than negative 1, we have increasing function. So if we put that into interval notation, negative 1 infinity. And 1 plus x is less than 0 when x is less than negative 1. So from negative infinity to negative 1, we are decreasing. And that's really all there is to it. So just find out when the derivative is positive, find out when it's negative, and that'll tell you when it's increasing or decreasing. So one note I want to say about justification, less is more. Just like when we do speeding up, slowing down, right? Speeding up when the acceleration and velocity have the same sign. Slowing down when they have opposite signs. That's all you need to say. That is the perfect amount of justification. Same here. If I have to give you a function like f of x equals, let's do 3x squared minus 2x plus 1. And I say, is the function increasing or decreasing at x equals, I don't know, let's make something up, 7. Okay? All you do, take the derivative, f prime of x, 6x minus 2, and you plug in 7. Okay, so 42 minus 2 is 40. What is the important thing about 40? It's positive, right? So at 7, the derivative value is positive. So at x equals 7, f prime of x is greater than 0, so f of x is increasing. Don't write a novel. Oh, come on. We're doing so well. Don't write a novel, right? You don't have to write a million things. You can even just say f prime of 7 greater than 0, therefore f of x increasing. Okay, something like that. Very short and sweet. Your grader will love you if you do something that short. Okay, believe it or not, that's it. So we kept it under 6 minutes. Huzzah. Love you guys. That's why I'm here. Have an excellent day. Catch you later.